A regular n-gon, or polygon, is a convex polygon with n sides that are all going to be equal in length, and all interior angles are going to be the same measure. And the regular n-gon or three-gon is a triangle that's an equilateral triangle. All of these are going to be 30 or 60 degrees, and all these side lengths are equal. That's what an equilateral triangle is. For a four-gon, four-sided shape, right, this is going to be a square. All the side lengths are equal, and all the angles are 90 degrees. For a five-gon, this is going to be a pentagon. Penta means five. They're all equal in length, and all these measures are going to be equal in measure. And these angles are going to be equal in measure. Six-gon is going to be a hexagon. Seven is heptagon, octagon, nonagon, decagon, hendecagon, dodecagon. And it keeps on going on, and to infinity. The perimeter, of course, of these are going to be, well, there's n side lengths, and they're all the same measure. So for a regular n-gon with side length x, the perimeter of this is just going to be n times x. So a decagon, which is a 10-sided shape, where all the side lengths are 3 inches. So this is 3 inches, 3 inches, 3 inches, 3 inches, 3 inches, 3 inches, all the way on around. There's 10 of them. Is just going to be 10 times 3 inches, or 30 inches. That's the perimeter for that example. Now, as you can see, as n increases, right, we get this shape, this shape. It's not looking very smooth, but as it increases, right, this is looking more and more like a circle. In fact, we can think of a circle as an infinitely sided polygon. That's a regular polygon. However, if you have infinite sides, right, you can't just take infinity times a distance. That's going to be pretty much zero. That doesn't make any sense. So perimeter doesn't make sense for a circle. Instead, we use the word circumference because it's a different type of thing. It's still the measure of the outside of a circle, just like a perimeter is the measure of the outside of a shape. Now, the constant pi, this is defined as the circumference of any circle. It doesn't matter which circle it is, and dividing by that circle's diameter. The diameter is just the distance across the circle, and that distance has to go through the center of the circle. It's going to be the longest distance you can get with that kind of a measurement. The value for pi is always the same. It doesn't matter what circle you're talking about. Now, if you take the circumference of that circle divided by its diameter, you'll always get this constant number pi. The circle will be super large or super small. It'll always be the same number. And we know this constant to trillions of decimal places. It's getting more and more each day. So this is what that means. Pi, this constant number, is the circumference of the circle divided by the diameter of the circle. What I can do is I can multiply both sides by d, and that's what I have here. And that will end up canceling the d, right? If you have a division by 3 and then you multiply by 3, the 3's cancel. If you have a division by 5 and you multiply by 5, those 5's will cancel. And that's what gives us just the c on the right-hand side and pi times diameter. This is a formula for finding the circumference of a circle if you know the diameter of the circle. Now, a more useful measurement than the diameter is the radius. And the radius is halfway from the side of the circle to the center. So this tends to be more useful than the diameter. The diameter you can see here goes through the center of the circle. The radius goes from the center out to any point on the edge, right? This is also the radius. This is also a radius. This is also a radius. It just goes from the center straight out to the edge. A diameter is anything that goes all the way across through the center. So this and this, that would be a diameter going all the way across the circle. And of course, if we start at this point and go all the way around, measuring this circle all the way around, this is what the circumference measures. And as you can see that the radius, right, let me clean this up. The radius goes from the center to the outside edge, but the diameter goes through the center to the outside edges, which means this is a radius and this is also a radius. The diameter is just twice the radius. So if we have this formula here, c equals pi times diameter, all I'm going to do is I'm just going to replace the diameter with twice the radius. And that gives me that c equals 2 pi times the radius. I'm just rearranging this a little bit. This is 2 pi times the radius. That's what gives us this formula here. You can find the circumference from the radius. And kind of similar to how I did this one, right? If we have 2 pi times the radius, I can get rid of the 2 pi by dividing. That's going to end up canceling the 2 pi. These cancel. And we get just the radius by itself and circumference over 2 pi. So this tells us a way of finding the circumference of a circle, or the radius of a circle, if we know the measure of the outside of it, the circumference. So the important formulas to keep in mind here are going to be this one, and this one here. Also remember that the diameter is twice the radius. That's just straight from the definitions. Okay, what are the circumferences for the following circles? Well, here we know the radius, right? This is the center of the circle here, and this is the outside edge. This is the radius. The radius equals 4 inches. And we know the circumference is 2 pi times the radius. The radius is 4 inches. And we're going to use the pi symbol on the calculator. There's no reason not to use that. Pi is known very accurately. So always use that pi symbol and then round when you get to the end. So this is going to be 2 times pi times 4. That's going to give me approximately, I'm going to round to 2 places, 25.13, and this is in inches. The radius is in inches, so the circumference is going to be in inches. Okay, here I know the diameter. It goes all the way across through the center. This is the diameter. And the circumference of the circle is pi times diameter, 12.44. So, using the pi symbol, 12.44. I'm going to run it 2 places again, so I should say approximately 39.08. This is in meters, so this is going to be in meters as well. Okay, here we have a simple diagram. We're going to have a circle with radius 7 inches. The diameter is twice the radius, so it's going to be 14 inches. And the circumference, we can use either formula, pi times diameter or 2 pi times the radius. It doesn't matter which one. Let's just use pi times diameter here. We have pi is the button on the calculator times the diameter of 14. So this is going to be pi times 14. Gives me 43.982 inches, rounded to 3 places. I should say approximately there. Okay, now if we know the circumference of a circle, then we can find the radius using this formula here, right? 450 kilometers, so we're going to have 450 kilometers divided by 2 pi. That's going to give us the radius. And I am getting 71.62 approximately. And that means the diameter is just going to be twice this amount. So go 71.62 times 2. The diameter is 143.24. And this is in kilometers for the circumference. So these are going to be in kilometers for the radius and diameter. All right, we're asking what are the distances around these compound shapes? So we're going to be finding the perimeter, and then if there's a circular area, we're going to find the circumference of that portion. Now, we're going to have to make some assumptions here that this is going to be half the circle. If it's not shown, if it's not said explicitly, but it looks like it's half the circle, assume it's half the circle. You can see here we have a triangle, and this triangle looks like an isosceles triangle. Since it's not told us to be isosceles, we have to assume it. There's no other way we can know this side length here, but to assume that this is an isosceles triangle. Okay, we also know that the distance, right, is going to be this distance here plus this distance here plus the circumference of this half circle. Well, is half of a circle is it the same thing as half the circumference? We know that this distance here is the diameter of this circle, right? If we were to continue the circle on this way, this would be the diameter. So the circumference of the full circle is going to be pi times diameter, which is 3 millimeters. Rid of that. But we want to have half of this. So really we're going to find half of the circumference. So it's going to be pi times 3 divided by 2. And I'm getting approximately 4.71 rounded to 2 places there. And now the full distance is going to be 10 millimeters plus 10 millimeters plus 4.71 millimeters. It's going to be 24.71 millimeters is my distance around this shape. Okay, for this one, again, we're going to make some assumptions. This looks like a rectangle, 90 degrees there. So this is going to be 0.7 feet. We are told that this is 1/3 of a circle, and that this radius here, right, this is the radius, is 1.2 feet. Well, if this is the radius, that means this is actually also the radius. This is also 1.2 feet. That's not necessarily helpful, but this portion is helpful. This is 1.2 feet there. And this is a parallelogram, which means opposite sides are equal. If this is 1.2 feet, this here is also 1.2 feet. And actually this portion was helpful because we can find this length here, which we need to find this length here. This length is going to be this full length here, subtracting off this length here. That gives us this portion, which is exactly what we want to find. So 1.7 minus 1.2 is going to give us 0.5. If that's 0.5, this here is also 0.5. So the distance around this shape, right, is going to be this, 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 and then this circle here, or this portion of the circumference, all added up. So I'm going to write that down. I'm going to start down here and go around. I have 0.5 plus 1.2. That's this one and this one. We're going to go up here, 0.7. Then across here is 1.7. Then down is 0.7. And then we have to add up this portion of the circumference. Well, this is 1/3 of a circle. We know what the radius is. So we can use the formula. The circumference equals 2 pi r. We're going to find 1/3 of the circumference. We're going to find 1/3 of this. So we're going to do the circumference equals, so 1/3 of that, we 2 pi times the radius of 1.2 feet divided by 3. So we just need to add on to this whole expression here, 2 pi times 1.2 over 3. Okay, let me add up this portion here just to get a number there. Gonna be, this is all 4.8. And then this is 2 times pi times 1.2 divided by 3 is 2.51 feet. So in total it's going to be 4.8 plus 2.51. I'm getting 7.31 feet approximately, right? Because this is approximate. That is the distance around this shape. Okay, for this one we have a bunch of half circles, and we're going to add up this distance, this, and then go all the way across the bottom. That's going to be the total distance we need to calculate. Well, we're going to assume that all these half circles are the same measurement here, and what we can see here is that this is going to be 6 inches. This is the radius, So all these have a radius of 6 inches. So we have the half circle here, right? This is going to be 4 half circles. You could also think of them as, right, 2 full circles. We just grab this portion, move it over here. I have 2 full circles. Same idea. However you think about it, that's fine. So we're going to have 4 of them total. And then they're going to be half the circumference. So the circumference divided by 2. And we have the radius. The circumference equals 2 pi times the radius. And we find half of this. So we're going to find half of this. What that's going to do is going to give us 2 pi times the radius 6. And actually this 2 and that 2 will cancel each other. So really all we have to do is do pi times 6. And we're going to have 4 of those. So 4 times pi times 6. I'm getting 75.3, 75.4 if I round to one place. Inches. That's going to be this distance all combined. And we also have this, and this. And they're all those individually are going to be the same portion, right? This is the same as this, which is the same as this, which is the same as this. And what is that? That is the diameter of these circles because it's going straight across the sides. We're assuming that this is the center because this is where the radius is. And that means that this distance goes straight through the center all the way across the circle, which is a diameter. This is the same thing as saying this is the radius and this is the radius. This is the center, right? This is 6 inches. This is the radius. This is the radius. Radius, 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 radius. So that it's either 4 diameters or 8 radii. Same idea. Since we have 8 of the radius, then we're going to have 8 times 6, which is 48 inches. So in total, we're going to have 75.4 inches and 48 inches. And I'm getting a total distance around this shape, 123.4 inches. Okay, this compound shape, let's see, we're going to have, this is a half circle here. Once again, we have to assume that. And this is the radius, right? This would be the center of the circle if we were to continue it. That would be the center there. That's the radius. And we're going to assume that this is a rectangular shape. So this is going to be 10.4 centimeters. We have to assume that. And this distance here is going to be 18.4 centimeters as well. So we know what this side, this side, this side are. Now for this side, right, we have to include this portion here, and this portion. These two portions really come from the fact that we know that the full distance is 18.4, and at the radius, right, this is 7.1. That means that this length here is 7.1, and this length here is 7.1. That's how a radius works. You can spin it all the way around the circle. So this is 7.1. This is 7.1. We need to take that off of this full distance here, and that will tell us this distance plus this distance. 18.4 minus 7.1 minus 7.1, 4.2, that's going to be centimeters. So just clean this up again. If this was x and this was y, then x plus y equals 4.2 centimeters. All we have to find then is this distance here, and this is just the circumference. Even though it's on the inside of the circle, if you think of it that way, the inside and the outside of the circle are really the same measurement because there's no width to the circle. Unless it's specified, there is no width. So this is just the circumference, and this is going to be half of the circumference, right? Since this is a semicircle, half of the circle, we're going to have half the circumference. So the circumference over 2 equals 2 pi r over 2. And r is 7.1. Of course, these two once again cancel, and we have pi times 7.1. So this distance is just pi times 7.1. and I'm getting approximately 22.31 centimeters. Okay, now we can find the full perimeter, or the full distance around this compound shape. We're going to get this distance, right, is x and y. That's going to be 4.2. We're also going to include this one, which is 22.31, plus this distance, plus the 18.4, and adding on to that also this distance here. That's going to be the full outside distance of the shape. Adding that up, I'm getting 65.71. These are all in centimeters, so this is going to be in centimeters as well. The radius of the Earth is approximately 3,961.3 miles. If a satellite orbits a distance above 3,000 miles above the Earth, so this should just be a distance 3,000 miles above the Earth, how many miles would it travel in one trip around the planet? So we have the Earth, and the radius of the Earth is approximately 3,961.3. That's an approximately. The Earth isn't a perfect sphere, so that's not going to. That's just an average of the radius. Now, a satellite orbits above the surface of the Earth an additional, right? It's going to be additional 3,000 miles. So the satellite, of course, does a circular orbit around the Earth. And the distance of this orbit is the same thing as the miles that it would travel around the planet, right? This distance here is the circumference, if I drew a perfect circle, right, is the circumference of this orbit path. So all we have to know for this is the radius or the diameter, and then we know the circumference, right? 2 pi times the radius. Well, the radius of this is just going to be this distance plus this one. Well, we know both of those, right? That's going to be the radius of the Earth and the radius, or the distance from the surface of the Earth to the satellite's position. So the radius is going to be 3961.3 plus 3,000, so 6961.3 miles. That means the how many miles would it travel in one trip around the planet? That's the circumference of this orbit. Let's see, it's going to be 6961.3 miles. Plugging that into a calculator, we get 43,739. Do just one place, 0.1. And this is going to be in miles since the radius was in miles. Okay, Roberto rides his bike along a rectangular path that is 7 miles by 1.5 miles. So it's not going to be a perfect rectangle because you would never, do a perfect angle like that. But we're going to estimate it with a rectangle. And do that something like that. 1.5 is the smaller side. 7 is the longer side. Now you want to try a new trail around a circular lake. So the lake is like this, probably not exactly a circle, but there's a trail around it. And it says we're assuming that the radius of 0.9 miles, this has to be the radius of the track because we don't know how far the distance is from the path. So we're going to assume that 0.9 miles is the radius to the circular trail. How many trips around the lake is the same distance as the rectangular one? So the perimeter of this, right, if we just do one trip around this, is going to be 7 plus 1.5 plus 7 plus 1.5. That's 1.5 and 1.5 is 3. 3 and 7 is 10. And plus 7 is 17 miles. So it's 17 miles around this trail. For this one, right, the distance here is going to be the circumference of the circle. So 2 pi times the radius of 0.9 miles. And that's going to be 5 5.65 miles, and this is approximate. So how many times does he have to go around this one to be the same as 17? That's what division can find, because we're asking how many times can this number go into this number. 17 divided by 5.65, and I'm getting approximately 3. Right? If you do 3 times 5.65, you get 16.95, which is just about 17. So yeah, he has to go 3 times around this trail to get the same distance that he's used to doing a 1 time around this rectangular trail.